Nagabhushanam, CH, Department of Physics, K.B.N College, and welcome to the physics class heat and thermodynamics, and it is the first unit kinetic theory of gases. In this class, mainly we will learn about some definitions of the speeds like average speed, most probable speed, and the root mean square, and transfer phenomenon, and viscosity, thermal conductivity, and the diffusion of gases like. First of all, what is the average speed? So the average speed it is represented by the letter C bar, and it is the speed of all the particles divided by the total number of particles. Suppose n is the total number of particles, and the total speed means the sum of the all particles n divided by the total number of particles n. And the formula, the average speed is given by C bar is equal to square root of 8 kT by pi m, where K is the Boltzmann's constant and T is the absolute temperature and m is the mass of the molecule. And the next one is the most probable speed. It is the speed possessed by the maximum number of molecules in a gas sample, and it is given by Cp is equal to square root of 2 kT by m, where K is the Boltzmann's constant and T is the absolute temperature and m is the mass of the molecule. And the last one is the RMS speed. That means the root means square speed CRMS. It is equal to square root of 3 kT by m, where K is the Boltzmann's constant and T is the absolute temperature and m is the mass of the molecule. And it is defined as the square root of the mean of the algebraic sum of the squares of the speed of the molecules. And the important topic in this class is the transport phenomena, and there are the three different quantities like viscosity, conduction, conductivity, and diffusion. So the first of all, the viscosity means it is the viscous force existing between the different layers of the gas, and it is explained with the help of this is simply there are the given three different layers A, B, C, D and E. Suppose AB is the reference layer, and U is the velocity of the gas molecules in this layer, and the velocity in upper layer CD the U plus lambda into du by dy, and in a lower layer is the U minus lambda into du by dy. So here from these three layers we observe that as the height increases from the x axis, the velocity increases. So the different layers having different velocities. So here the momentum is also different. So here the momentum is different, layers having different. So there is the phenomena is arising the viscosity due to the transport of the momentum from one layer to the other layer. So here due to the viscous force existing between these layers, there is the phenomena is arising the viscosity. So it is defined as the tangential or the viscous force existing between the layers per unit area per unit velocity gradient, and it is given by the mathematical expression eta is equal to f by du by dy, where du by dy is the velocity gradient, f is the viscous force, and eta is the coefficient of viscosity, and here the letter lambda is the mean free path. That means it is the average distance between the molecules collision. That means it is the distance existing between the consecutive collisions among the molecules. And here its derivation is here there are the three different layers C, A, B, C, D and E, and here the velocity is the different, and in the layer the velocity is more, and the velocity in layer EF is low, and in middle layer the velocity is the U, and here m is the mass of the molecule and n is the the concentration, C bar is the average speed, and lambda is the mean free path. See here, the momentum is the more in the layer CD, and less the momentum is less in layer EF. So here the momentum is transferred from CD to EF through AB, and in the same time the momentum is transferred from EF to CD through AB. So here the net momentum change transported from unit area per unit velocity gradient is the is 1/3 mn c bar lambda du by dy, and it is the momentum transport per second. So it is according to Newton second, it is also equal to the force. So here according to the definition of the viscosity, the viscosity coefficient is defined as the ratio of the viscous force to the velocity gradient. So the coefficient of viscosity is equal to mc bar by 3 root 2 pi d square, where m is the mass of the molecule, c bar is the average speed, and d the diameter of the molecule. And the thermal conductivity here it is defined as the heat energy is passing per unit area per unit temperature gradient. So here the conductivity is obtained by transporting the heat energy or the kinetic energy, and it is obtained by different layers having different temperatures. So the energy is also different, kinetic energies. So here the temperature in the reference layer AB is suppose it is the T. As the height increases, the temperature is also increase, and the height decrease, the temperature is also reduces. So from this graph we observe that different layers having different temperatures. So energy is also different. So the energy is transmitted among the layers, and the energy is transported per unit area per unit temperature gradient is called the thermal conductivity, and it is denoted by the symbol K, and mathematically it is given by Q by dt by dy, where dt by dy is the temperature gradient. And the conductivity K is equal to 1/3 rho C bar Cv lambda, where rho is the density, C bar is the average speed, and Cv is the specific constant volume, and lambda is the mean free path. And the other one is the transfer phenomenon. The last one is the diffusion of gases, diffusion. And here there are the 3 layers, and density also different. So the number of molecules in layer XY is suppose n, and in the layer as the distance increases, the density is also increase. So the number of molecules are the mass of the molecule is also transporting from one layer to the other layer. And the coefficient of diffusion is defined as it is the ratio of the number of molecules crossing per unit area per second to the concentration gradient. And finally the diffusion coefficient is equal to eta by rho, where eta is the coefficient of viscosity and rho is the density. Thank you. సార్ క్వశ్చన్ ఏమవుతుంది కదా సార్ అంటే చూసుకుంటాం.